Welcome to this comprehensive course where we will build 3 cutting-edge AI agents from scratch. First, you'll create a sophisticated sales agent that can engage in natural, real-time conversations with customers, leveraging the power of LiveKit and Cartesia. Next, you'll learn to build a powerful deep research agent using Exa, capable of searching the web, analyzing multiple sources, and delivering structured insights in seconds. Finally, you'll learn how to construct a user research agent with LangChain that can automate the entire research process, from generating user personas to conducting simulated interviews and synthesizing feedback. Each project is designed to be hands-on, providing you with the practical skills to develop your own functional AI agents. Thanks to Cerebras for providing a grant to make this course possible.
Hi, I'm Sarah Chang, a growth engineer at Cerebras, and I'm so excited to welcome you to our 3-part hands-on workshop series designed to help you build powerful AI applications. Across these workshops, we'll build everything you need to get started with real-world AI use cases, from voice agents to deep research assistants to multi-agent workflows. You'll get sample code, practical exercises, and open source example repos so you can follow along and build. We'll also dive into today's most popular AI tools and frameworks, showing you how to incorporate fast, cutting-edge inference into your projects. Let's get into it. I can't wait to see what you build. Welcome everyone to Build Your Own Sales Agent. I'm Sarah Chang from Cerebras, and I'm so excited to be joined by Russ Desai, CEO of LiveKit today.
Thanks, Sarah. Today, we're going to be walking through how to build a voice sales agent that can have natural conversations with customers. Our sales agent will pull product context from an external source and can respond in real time.
This isn't just a simple chatbot. We're building a full-featured AI agent that can speak, listen, and respond intelligently using your company's sales materials. By the end of this workshop, you'll have your very own working sales agent that can handle customer inquiries just like a human would.
We have a complete code notebook for you to follow along with, and you'll be able to keep experimenting and building even after today's workshop is over.
Before we get started, let's go over what you'll get out of this workshop. Free API credits for LiveKit, Cerebras, and Cartesia, a complete quick start guide to build apps with our technologies, and your very own functional sales agent that you can customize. Before we dive in, please make sure you have the notebook open. If you haven't already, go ahead and click on the collab link we shared.
Let me start by showing you what we're building toward. In the future, most customer interaction will be AI powered, but instead of just typing back and forth with a chatbot, you're going to have a real conversation using your voice.
Voice agents are becoming the new frontier because they're more natural, more engaging, and frankly, more human than traditional chatbots. When someone calls your business, they want to talk to someone who understands them, not navigate through a phone tree. So Russ, taking a step back, what exactly are AI voice agents?
AI voice agents are stateful, intelligent systems that can simultaneously run inference while constantly listening to you speak. They can engage in real, natural conversation. They have 4 key capabilities. The first is that they understand and respond to spoken language. They don't just spit out answers based on string matching or keywords. They understand the meaning behind what people are saying. This means they can handle complex tasks and questions. Someone might ask, I'm looking for a product recommendation. The agent can look at the user's purchase history, the shop's current stock levels, and recommend something they'd like. You might see this referred to in some places as multi-agent or workflows. Speech is the fastest way to communicate your intent to any system. When you can just say what you want, there's no typing, no clicking through menus, and no learning curve. People have been speaking to one another their whole lives, so a computer system with the same interface can take advantage of that familiarity. Lastly, none of this is possible unless the agent can keep track of the state of the conversation. Communication is highly contextual, and your agents need to have state so they can hold a coherent conversation across time.
I see. And I imagine this makes them perfect for things like customer service, sales conversations, like qualifying leads and answering product questions, technical support, walking people through solutions step by step, or even information retrieval, finding exactly what someone needs from your knowledge base.
Now, let's talk about what's actually happening inside the voice agent when you're having a conversation. The first step in this pipeline is a transcription phase, or ASR, automatic speech recognition. Ideally, we only want to send speech, not silence or background noise, to our speech-to-text model. To help with that, we add a small VAD, voice activity detection model, in front of STT, which detects if what's being picked up by our microphone contains human speech. We'll use VAD to filter out any audio that isn't human speech before it reaches STT. This improves the accuracy of our STT transcription, helps with understanding when you're done speaking, and the LLM can start speaking. It also saves you a ton of money by not having to constantly stream audio to the STT model. Once speech is detected, the voice data is forwarded to STT. This model listens to and converts your words to text in real time. The last step in the layer is end of utterance or end of turn detection. Being interrupted by AI every time you pause is annoying. While VAD helps the system to know when you are and aren't speaking, it's also important to analyze what you're saying, the content of your speech, to predict whether you're done sharing your thoughts. We have another small model here that runs quickly on the CPU. It will instruct the system to wait if it predicts you're still speaking. Once your turn is done, the final text transcription is then forwarded to the next layer.
Then comes the thinking phase. Your complete question gets sent to a large language model. Think of this as the brain that understands what you're asking. The brain might need to look things up, like checking your product catalog or calling other services to give you the right answer. Once it figures out what to say, it starts generating a response sentence by sentence.
The third and final step is the speaking phase. As the LLM streams a response back to the agent immediately starts forwarding those LLM tokens to the TTS engine. This generated audio from TTS streams back to your client application in real time. That's why the agent can start speaking while it's thinking.
And the final result, a conversation that feels natural and immediate, even though there's a lot of complex processing happening behind the scenes.
There's a lot of moving pieces here, but LiveKit's Agents SDK is going to handle all this orchestration and data management for us. It manages the audio streams, keeps track of context, and coordinates all these different AI services so you don't have to worry about the technical plumbing.
Awesome. And now that we have our bases covered, let's get everyone set up. You can access the starter code here. This will take you directly to our Google Colab notebook where you can see the starter code for today. First, we need to install all the necessary packages. In your notebook, find the first code cell and run it. You'll see this command. Go ahead and run that cell now. Click on it and press Shift and Enter or click the play button. While that's installing, you should see some output showing the packages being downloaded. This installs LiveKit agents with support for Cartesia, Celero for voice activity detection, and OpenAI compatibility. While you're pulling that up, let me explain the key technologies that make this project possible. First, let's talk about the brain of our operation, the LLM. For today's workshop, we're using Llama 3.3 70B, which is from Meta's latest family of open source AI models running on Cerebras, the lightning-fast inference.
Speed is always critical here. You can have the most sophisticated LLM available, but if the inference is slow, the conversation feels slow and broken.
Exactly. And that's the challenge most voice agents face today. If you're using traditional GPUs, you're looking at 5 to seconds per response. For a phone conversation, that's just painful.
Nobody's going to wait around for that. They'll just hang up.
So that's where Cerebras comes in. We're about 50 times faster than traditional GPUs, so instead of those multi-second delays, you'll get responses in milliseconds. When someone asks the AI sales agent, "What's your pricing?" they expect an immediate answer, just like they would from a human.
For voice agents, speed isn't just a nice to have. It's table stakes. When people talk to each other in everyday conversation, they have less than 500 milliseconds of total latency between turns. When we stretch AI agents' response times too far past that, it stops feeling natural.
And as a final note on Cerebras, this is the AI processor running these models, the Cerebras Wafer Scale Engine WSE3. It's a massive AI chip that delivers the fastest inference in the world. As you can see in the benchmark, we're delivering 2,591 tokens per second with Llama 3.3. That's 5 times faster than the next best provider.
First, let's install the LiveKit CLI. This is optional for our workshop today, but if you want to use LiveKit beyond this, here are the commands depending on your system. Today, we're using a Python notebook so that nobody needs to battle with their environment when they're getting started. But if you want to build and deploy any agents that other people can interact with, the CLI is by far the easiest way to do it. Just type LK app create and instantly clone a pre-built agent like the one we're about to build here. Let's talk a bit about what exactly LiveKit is and why we need it for our voice agent. The existing internet wasn't really designed for building voice AI applications. HTTP stands for Hypertext Transfer Protocol. It was designed for transferring text over a network. For what we're building, we need to transfer voice data over a network with low latency. LiveKit is a real-time infrastructure platform for doing just that. Instead of HTTP, it uses a different protocol, WebRTC, to transport voice data between your client application and an AI model with less than 100 milliseconds of latency anywhere in the world. It's resilient, handles any number of concurrent sessions, and is fully open source. So you can dig into the code and see how it works, or even host it yourself if you want. You can use LiveKit to build any type of voice agent, including ones that can join meetings, answer phones in call centers, and in our case today, an agent that can speak to a prospective customer on your website.
Here's the key part for Voice Agent. LiveKit acts as middleware between your AI and your customers. When someone wants to talk to your agent, LiveKit makes sure the audio gets from their phone or computer to your LLM and then gets the LLM's response back to them, all in real time.
We take care of the hard parts so you can focus on your application. Connection management, routing information between data centers, traversing firewalls, or adapting to spotty cellular connections. You don't have to worry about any of it. Our goal is to make building a voice agent as simple as building a website.
Here, you can see those boxes labeled LLM, TTS, and STT. Those are the AI components we talked about earlier that help the agent listen, think, and speak.
LiveKit is the real-time layer, ensuring data flows smoothly between your customers and all of your AI components.
In addition to Cerebrus and LiveKit, we will also be using Cartesia. The final component we need is the actual speech processing. To turn voice into text and text back into voice, we need specialized models. That's where our partner Cartesia comes in.
Cartesia has their own flavor of Whisper Large V3 Turbo called Ink that's focused on real-time accuracy and time to first byte latency. When you talk to our sales agent, Ink converts your speech into text that the AI can read and understand. Ink is pretty fast. Transcriptions come back within 60 milliseconds of you finished speaking.
Then, when the AI has something to say back, Cartesia takes that text and converts it into speech that sounds natural and human-like. It's like having a really good interpreter who works both ways. They also handle all the messy parts of human speech, like when people pause or interrupt each other or say a lot. Now, let's take a moment to set up our API keys for Cerebrus, LiveKit, and Cartesia. In the second code cell, you'll need to replace the placeholder API keys with your actual keys. The links to get these free API keys are all in your notebook. Now that our API keys are set up, step 2 is about teaching our AI sales agent about your business. Think of it like training a new employee. You would put someone on the phone without telling them what you sell, right?
The challenge with LLMs is that they know a lot about everything, but they might not know many specifics about your company. LLMs are only as good as their training dataset. If we wanted to respond with information that isn't common public knowledge, we should try to load it into the LLM's context window to minimize hallucinations or the "I can't help with that" responses.
This is where something called RAG comes in, Retrieval Augmented Generation.
This process is simple in concept. We feed the LLM a document containing additional information. For example, if we load our pricing details into the LLM's context window, then when someone asks about pricing, it's easy for the LLM to look up that information and return an accurate answer.
So for this demo, we'll load in information like product descriptions, pricing info, key benefits, even pre-written responses to common questions, like "it's too expensive." That way, our agent always stays on message and has the context it needs to generate accurate responses.
Let's take a look at our notebook and see what that added context looks like in practice. Under step 2, we've organized all the information our sales agent needs into a simple, structured format that's easy for the AI to understand and reference.
You can see we have everything a good salesperson would need. A clear product description that explains what we're selling, a list of key benefits that highlight why customers should care, and specific pricing for each tier. But here's the really fun part. those objection handlers at the bottom. These are pre-written responses to the most common things customers say when they're hesitant to buy.
When someone says it's too expensive, the agent already has a proven answer ready. For example, I understand the cost is important. Let's look at the ROI. Most clients see 3x return in the first 6 months.
When they say, I need time to think, the agent knows to ask, what specific concerns can I address right now, rather than just saying, okay, call us back.
This gives your agent a loose script. You can fill this with the responses that have converted best for your sales team. LLMs are non-deterministic, so it's not going to say the exact same thing every time, but it provides a solid framework for the agent to follow while it's talking to prospects.
Now let's fill out our load context function and load this information into our agent and see how it uses this knowledge during conversations. Next is the exciting part, step 3, where we actually create our sales agent. This is where we take all of those components we just talked about and wire them together into a working system.
Before you run anything, let's walk through what's happening in the sales agent class. We start by loading our context using the load context function we defined earlier. This gives our agent access to all the product information, pricing, and objection handlers that we set up. Then we configure the 4 components that are part of our voice pipeline. The LLM is a Llama 3.370B running on Cerebras. Llama 3.370B is a good balance between speed and quality, and it's great at tool calling, which we're going to need later. For speech-to-text, we're also using Cartesia's Ink Whisper engine, which is really fast. On the text-to-speech side, we're using Cartesia again, partially because it means you only need one API key, but also because their TTS engine, Sonic, is also really fast. For voice activity detection, we're using Celero, which is the default option for the agent's framework and has a light footprint and really fast performance.
Now let's look at how we actually implement this in code. The instructions are important, but if we try to show the whole prompt here, the text would be really small. The full version is in your notebook. We start by telling the agent, you are a sales agent communicating by voice, and give it important rules like don't use bullet points because everything will be spoken aloud, and most importantly, only use context from the information provided. If someone asks about something not in the context, say, you don't have that information.
The super call initializes our agent and passes all of our configurations to the parent agent class. This sets up the agent with our LLM, STT, TTS, VAD, and instructions all working together.
We also define an on-enter method to start the conversation. This is triggered as soon as someone joins a conversation with the agent. Instead of sitting in silence, it immediately generates a greeting and offers to help, just like a good salesperson would. Now go ahead and let's run the step 3 cell to define our sales agent class.
Step 4 is our launch sequence. This is how we actually get our agent up and running so people can talk to it.
Think of this entry point as the start button for our agent. When someone wants to have a conversation, this is what kicks everything into gear and gets the agent ready to talk. The entry point function does 3 main things. First, it connects the agent to a virtual room where the conversation will happen, like dialing into a conference call. Then, it creates an instance of our sales agent with all the setup we just configured. Finally, it starts a session that manages the back and forth conversation. This session glues together all of our model configurations, media streams, tool configurations, and maintains the conversation history.
Usually, you'd have a front end like a mobile app or a web page where you're speaking to your agent. But today, to make it easy, we're going to create a minimal web interface right here in the notebook.
Before we run this, let me set expectations. When you execute this cell, it's going to load several AI models and establish connections to multiple services. The first time might take 30 to 60 seconds, so be patient.
Once you start your agent up, you'll see some initial log output. You can think of this as similar to booting up a Next.js app or a web server. Your agent server waits for new conversation requests from your customers. When a request comes in, LiveKit will connect your agent and front end together so you can start speaking.
Go ahead and run the step 4 cell now. Watch the output and wait for the interface to load.
If you see any errors about expired tokens, just stop the cell and run it again. The cell will request a new room join token from the Jupyter proxy, and you'll be able to connect to the room.
Great, now we have a fully working sales agent, but let's keep going to make it even more robust. This part here is completely optional, but here are a few ways you can expand your sales agent. First, let's stop the current agent by clicking the stop button on the cell that's running, or pressing the interrupt button in your notebook.
Now, one thing we can do is expand our single agent into a multi-agent system. Why would we want to do that instead of just having a single one to answer every question?
Great question. Think about how real sales teams work. You don't have one person who's an expert at everything, you have specialists.
If someone calls asking a deep technical question about some API integration, you want them talking to your best technical person, not your pricing specialist. LLMs have limited context windows, which means, similar to people, they have limits on the amount of things they can specialize in. We can also tailor the conversational style of the topics that we're talking about. If there's a conversation about technical issues, it's less important for us to talk about value props and ROI. In our case, we're not actually pushing in that much context, but this is an important lesson to learn when you're creating larger, more complex agents for production. For a more complex system, here are 3 agents that we've defined. A greeting agent is our main sales agent who qualifies leads. A technical specialist agent is specialized on solving technical issues. And a pricing specialist agent handles budgets, ROI, and deal negotiations.
The magic is in the handoffs. Our greeting agent figures out what the customer actually needs, then smoothly transfer them. Let me connect you with our technical specialist who can dive deeper into those integration questions.
Each specialist has its own voice, personality, and specialized knowledge. The technical agent can go deep on specs without getting wrapped up in trying to sell anything, while the pricing agent can focus purely on ROI and budget decisions.
It's like having your best sales team available 24/7. Go ahead and run the Enhanced Sales Agent cell. Now run the Technical Specialist Agent cell followed by the Pricing Specialist Agent cell. Finally, let's run the Multi-Agent Entry Point. This will start our new system with agent transfer capability. This multi-agent system also uses tool calling. When a customer asks about technical details, our agent can transfer them to a technical specialist who has a different voice and specialized knowledge. Let's implement this enhanced system. Scroll down to the challenges section and find step 5. First, run the cell that imports the function tool. This gives us the ability to create transferable functions. Now, let's look at our enhanced sales agent. You'll see we add function tools to allow agent transfer. And that's it. In less than an hour, you've built a sophisticated multi-agent voice sales system that can have natural conversations with customers, transfer between specialized agents, use your actual product information, and handle objections professionally.
Remember, you have free API credits for all 3 platforms, so keep experimenting. Try adding your own product data or customize or expand the agent personalities and voices. Maybe integrate with your existing systems or external APIs.
The code notebook will remain available to you, and we've included links to get free API keys for Cerebras, LiveKit, and Cartesia. If your agent isn't working perfectly right now, don't worry. Sometimes it takes a few tries to get the microphone permissions set up correctly, or you might need to refresh and run the cells again.
The most important thing is that you now understand the architecture and you have the complete working code to take with you.
Happy building! Welcome everyone to Build Your Own Deep Research. I'm Sarah Chang from Cerebras, and I'm here today with Will Brick, CEO of Exa. We're super excited to have you all here.
Thanks, Sarah. Today we're going to build something pretty cool, a deep research style assistant that can automatically search the web, analyze multiple sources, and provide structured insights in under 30 seconds. We'll code it up with you.
That's right, Will. By the end of today, we'll learn how modern AI-powered deep research systems work under the hood. So before we get started, let's do a quick overview of what we're walking away with today. First, free API credits for both Cerebras and Exa so you can continue developing after this workshop ends. Second, a complete quick start guide to build apps with both APIs so you can jumpstart your future projects. And third, your very own functional research agent that goes way beyond basic search.
Now let's see what we're building. This is Cerebras' deep research interface. It looks clean and simple, but there's some serious intelligence under the hood. Our coding today will build the functionality behind this. If you notice, it's not just returning search results. It's actually doing real research, searching multiple sources, analyzing the content, identifying knowledge gaps, and then doing follow-up searches to fill those gaps. You might take an hour to do all this work, but this app does it in less than a minute. Your deep research will be 10x faster than ChatGPT's deep research.
Before we dive into AI-powered research, let's talk about how research was traditionally done. In the old days before 2025, researchers somehow used to write their own research papers and reports. Let me walk you through each step as we build this diagram together. So first, it all starts with a research question. Once you have your question, you need to figure out where to look for answers. So you'd branch out in multiple directions, you'd go to the library to search through physical books and journals, you'd do Google searches, and if you were lucky, you'd interview experts in the field. After gathering all these sources from libraries, search engines, and expert interviews, what's the next step? You'd sit down and take notes.
Right. That means reading through literally everything you can, highlighting key passages, writing summaries, and keeping track of where each piece of information came from. You can imagine doing this with hundreds of sources.
And this is where human limitations really showed up. You could only read so much, process so much, and remember so much. Important connections between sources might be missed completely because of information overload. Finally, you take all these notes and compile them into an answer. This is where the real intellectual work happened, synthesizing information from multiple sources into coherent insights.
In reality, research is a recursive process. You never actually know if you found all the relevant information in the first pass, so you have to go back and do it again with your new knowledge. Each loop through this process could take hours or days, and there's always this nagging feeling that you might have missed something important. Luckily, AI can do days of research in 30 seconds.
Now, what do we mean when we talk about deep research powered by AI? AI-powered deep research incorporates all those research steps like gathering sources and analyzing notes, but uses LLMs to dramatically accelerate each step.
For starters, instead of going to the library or searching on Google, we use tool calling with a web search API, in this case, Exa. Our AI system can autonomously break down the initial research question into the web search API calls that would answer the question.
Next, instead of the take note step from traditional research, we have retrieval augmented generation, or RAG. RAG just means that the LLMs get to retrieve from the web before generating, because they don't have the whole web memorized and often make stuff up. With RAG, our web search API gives the LLM fully informed context, so it's super accurate.
Finally, instead of us manually reading and analyzing all of these notes, we let the large language model do it for us. And like traditional research, there's a feedback loop. Our AI system identifies gaps in its RAG output and triggers any new searches if necessary. This loop repeats multiple times until the LLM decides that the answer has been reached.
And because we're doing so many LLM calls, speed becomes absolutely critical. This is why we need Cerebras. When you're chaining together 10 or 15 LLM calls to complete a research task, even small delays can add up really quickly.
So now that we understand what AI-powered deep research is, when should you actually use it? Deep research takes a lot longer than a typical search, but it's perfect for things like answering really hard questions like what project to work on or what's the meaning of life, or keeping up with fast-moving fields like AI or biotech.
Now, let's get everyone set up to build our own deep research systems. You can access the starter code here. This will take you directly to our Google Colab notebook, where you can see the starter code for today. The notebook contains all the code we'll be working with, plus some additional examples and extensions you can explore after the workshop.
First, we need to install our dependencies and set up the environment. In your Colab notebook, you'll see we're installing ExaPy and Cerebras Cloud SDK. Run that first cell to get everything installed.
While that's running, let's go ahead and grab our API keys. You'll need a Cerebras API key, and you can get started for free at cloud.cerebras.ai, and an Exa API key, which you can also get for free at exa.ai. While you're installing these packages and getting your API keys, let me explain a bit more about Cerebras and Exa. First, let's talk about the brain of our operation, the LLM. For today's workshop, we're using Llama 4 17B Scout, which is from Meta's latest family of open source AI models running on Cerebras hardware.
Cerebras' speed is a huge unlock here. The faster the language model can run inference, the less time our users have to spend waiting for the research report to come back. Especially with deep research, where we're chaining together multiple LLM calls, speed is super important.
It's a great example of something you can only build with fast inference. Today, most deep research products take multiple minutes to return a report. Cerebras unlocks a completely different experience. We serve the top open source models in the industry with 50 times faster inference than traditional GPUs. This is the actual hardware making it all possible, the Cerebras Wafer Scale Engine WSE3. It's a massive AI chip that delivers the fastest inference in the world. As you can see in the benchmark, we're delivering 2,800 tokens per second with Llama 4 Scout, 5 times faster than the next best provider.
Now that we've covered how Cerebras will run our language model, the second component is to give our LLM search over the web. That's where Exa comes in. We built our search engine from scratch to connect LLMs to the web. X is actually built specifically for AIs, and we've built all the features to make it super simple. For example, we don't just return search results, we return the full content of each result page so that your LLM has full context. In fact, we're actually also the fastest search API in the world.
Now that our API keys are set up, step 2 is all about building our core search function using Exa. Looking at our research flow diagram here, this is the first red box, where we take a question and find relevant sources on the web. So let's build this search function and see how it works. In your notebook, you'll see step 2, where we define our search function. Here's what the function looks like in practice. On the left, we're creating a function called search web. Let me walk you through the actual code. Notice in our search web function, we're using the search and contents endpoint. This means that not only are we doing a web search, but for each URL returned, we're also getting the crawled content from that page. We also specify type auto. This is really powerful. It automatically chooses between keyword and neural search based on your query. You don't have to decide which approach to use. Think of it this way. If you search for something like Python programming tutorials, that's clearly a keyword search. But if you search for companies that are disrupting traditional banking, that's more conceptual and benefits from neural search. Exa figures this out automatically. The text parameter controls how much content we get from each source. For deep research, we want substantial content, not just snippets. This gives our LLM rich content to work with instead of trying to piece together tiny fragments. Go ahead and run this function now. Try searching for something like space companies in America and see what you get back. You should see both the search results and the full content from each page rendered as clean markdown.
On the right side of the screen, you can see the kind of results we get back. Notice we're not just getting titles and snippets, we're getting the full content of relevant pages. This is crucial for the LLM to do deep analysis rather than surface level summarization.
Now let's move to the next step in our flow, taking all those relevant sources we found and feeding them to our LLM for analysis. This is the next step in our diagram powered by Cerebras.
This is where the magic of RAG really happens. We're passing the LLM fresh, relevant information from the Exa API web search to work with. And this is where Cerebras' speed becomes critical. We're about to start chaining multiple LLM calls together, so each individual call needs to be fast. A few seconds here and there quickly adds up to minutes of waiting.
Now let's look at the actual implementation. Here's what's happening under the hood. We're taking all that rich web content from Exa and feed it directly to the Cerebras LLM along with our original question. In our Ask AI function, we're using a low temperature of 0.2. Think of temperature like a creativity dial. Lower numbers give you more focused, deterministic responses. Since we want factual analysis, not creative writing, we keep it low. The model we're using, Llama 4 Scout, is specifically optimized for reasoning and analysis tasks like this, and because it's running on Cerebras' WSE3 chip, you'll see responses in seconds, not minutes.
Look at how we structure the prompt. We're not just asking, what do you think? We're giving the LLM specific instructions. Analyze these sources, answer this question, and format your response clearly. The LLM reads through all the sources simultaneously, something that would take a human hours, and synthesizes insights in just seconds. This is the power of combining fast inference with comprehensive source material. You can now go ahead and run the Ask AI function with some sample content. You'll see how quickly it processes even large amounts of text and returns structured insights.
Now let's put it all together into a function called research topic. This is our basic research function that follows a classic flow. Ask a question, do an Exa web search, pass the relevant sources to the LLM, then return a response. If you walk through the research topic function in your notebook, you'll see it searches for sources using our Exa function, filters for substantial content, over 200 characters, creates context for the LLM, then asks the LLM to analyze and synthesize an answer.
The key is in the prompt structure. We're asking for both a summary and specific insights in a structured format. This makes the output much more useful than just a wall of text. Try running this on a topic you're curious about, something like climate change solutions 2025 or quantum computing advances. You should see it finds multiple sources and gives you a real analysis.
In the next and final step, we're going to expand on our basic research model. This mirrors how human experts actually research. Instead of just doing one round of web search and LLM synthesis, after the first web search, the LLM identifies the most important gaps in understanding and does a targeted second web search before producing an answer. Let's take a look at step 5, where we implement a basic recursive version of our deep research. If you look at the deeper research topic function, it does everything the basic version does, but then adds this intelligent follow-up layer. The implementation has 2 key steps. After the first analysis, we ask the LLM, based on these sources, what is the most important follow-up question that would deepen our understanding of our query? 2, we then search for that specific missing topic and combine both layers for our final analysis.
Again, look at the prompt engineering. We're not just asking for more information, we're specifically asking the LLM to identify gaps and formulate targeted search queries. This is much more sophisticated than just doing random additional searches. You can go ahead and run the enhanced version on the same topic you tried before. You should see much richer, comprehensive results.
Now that you have the core system working, let's talk about where you can take this next. The beauty of what we've built is that it's modular. You can enhance any piece independently. Some ideas for expansion include adding more search layers, integrating with specialized databases of academic papers, patents, etc., or adding different types of analysis and sentiment, trend detection, or competitive intelligence.
You could also experiment with different LLM models, add memory between searches, or even build domain-specific research agents for things like market research, academic research, or technical due diligence.
We could stop here, but for those who want to go deeper, we're going to look at the approach Anthropic uses for their deep research agent. This is completely optional, but it will give you an idea of what production systems look like. In the Anthropic approach, a lead agent breaks down complex queries into specialized subtasks, multiple sub-agents working simultaneously. Then the lead agent synthesizes everything together and decides whether to kick off more sub-agents or generate the final report. By splitting the task across agents, you keep the context manageable for each individual agent. Think of it like a research team where everyone has their own specialty.
This is huge for reliability. It makes sense, right? Humans also function better when they're given a well-scoped task versus trying to manage 10 things at once. Also, by running sub-agents in parallel, you can run dozens of searches while keeping the response time manageable. Instead of doing searches sequentially, you're doing them simultaneously. The Anthropic multi-agent research function in your notebook shows a simplified version of this approach. It's more complex, but it is better at handling difficult topics that require stringing together multiple sources.
And that's a wrap. You've just built a sophisticated research system that combines the best of web search and AI analysis. You now understand how modern AI-powered research works under the hood.
Remember, you have free API credits for both Cerebras and Exa, plus the complete code guide to keep experimenting. You should build something cool. The techniques you learned today, RAG, multi-layer search, intelligent follow-up, these are the same patterns used by production research systems that we use at places like Exa.
And us at Cerebras. Now, go build some amazing research agents. Welcome everyone to Automate User Research with AI. I'm Sarah Chang from Cerebras, and I'm so excited to be joined by Lance Martin from LangChain today.
Thanks, Sarah. Today we're going to walk through how to build an AI-powered user research system that can automatically generate user personas, conduct interviews, and synthesize product feedback in under 60 seconds.
This isn't just about automating surveys or forms. We're building a sophisticated AI research system that can generate end-to-end simulated interviews using LangGraph workflows. By the end of this workshop, you'll have your very own working user research system that can compress weeks of work into minutes.
We have a complete code notebook for you to follow along with, and you'll be able to keep experimenting and building even after today's workshop's over.
Before we get started, let's go over what you'll get out of this workshop. Free API credits for Cerebras, a complete quick start guide to build apps with Cerebras, LangChain, and LangGraph, and your very own functional AI user research system that you can customize. Before we dive in, please make sure you have the notebook open. If you haven't already, go ahead and click on the collab link we shared.
You can scan the QR code on the screen to access the starter code. Let's make sure that everyone has this open before we continue. So Sarah, taking a step back, what exactly is user research?
User research is a systematic process of gathering and analyzing information about your target audience. The goal is learning user behaviors and needs, validating product ideas, and making better product decisions. Everyone from startups to big companies like Google, Netflix, or Dropbox all have teams that conduct user research before launching a new feature or creating a product roadmap. It's something that all companies invest heavily in because it's essential for building products people actually want. It also takes an extremely long amount of time. So now let me walk you through how this is traditionally done. We always start with a user question. Then for each user, you create interview questions. This takes time to get right because you need open-ended questions that actually get useful insights. Bad questions lead to bad data. You need questions that reveal motivations, not just surface-level preferences.
That's right. Next comes recruiting participants, and this is where things get very expensive. You need to find the right people who match your target demographic. This is often the biggest bottleneck, finding qualified participants who represent your actual users.
Exactly. That's 2 to 3 weeks just to find the right people to talk to. Then you're scheduling interviews around everyone's availability. Coordinating schedules, sending reminders, dealing with no-shows is a logistical nightmare. Then conducting interviews, another 1 to 2 weeks of actual conversations, transcribing, and organizing responses. Each interview might be 30 to 60 minutes plus transcription time plus organizing all of that qualitative data.
And finally, analyze responses, pulling out themes, identifying patterns, writing up actionable insights. That's another week. And this is really where most research projects die. You have all this data, but turning into actual insights is a lot of hard work. And here's the complete timeline. User questions all the way through to final insights. All in all, we're looking at 6 weeks total, and that's if everything goes smoothly. This timeline really kills innovation speed. Startups really can't afford to wait 6 weeks to get user feedback.
By the time you get results, your product might have already changed, or your competitors might have moved ahead. In the era of AI-assisted coding, engineer teams can build products before PM and design teams can validate if they're a good idea to build. This 6-week research timeline is simply too long for modern organizations. And that's what's so exciting about what we're building today. What if we could automate this entire process? Instead of recruiting real people, we can create AI personas that represent your target users. AI user research creates multiple AI personas and runs hundreds of simulated interviews in minutes. We're talking about genuine AI agents that can think and respond like real users. So now, instead of scheduling interviews, we can simulate them instantly. The AI can roleplay as different types of users and give you realistic responses. Look at this. It's the same process, but every step is automated and happens in seconds, not weeks. Our system has 4 AI-powered components. We AI generate the interview question based on your research topic. Then, the AI creates diverse personas that match your target demographic. Next, the AI runs simulated interviews between the researcher and the persona. And finally, the AI analyzes all the responses to give you actionable insights.
That's right. Each step that took weeks can now take seconds, and you can iterate on research or product questions in real time. This is the magic. 6 weeks becomes 60 seconds. You can test multiple research approaches instantly and get feedback immediately. When you can test product feedback or ideas that quickly, suddenly you can iterate very quickly or instantaneously.
Now let's switch over to the code. You can access the starter code here, and we'll be walking through the notebook step by step. If you haven't already, make sure you have the starter code open. We're about to dive into the technical implementation. First, we need to install all the necessary packages. In your notebook, find the first code cell and run it. You'll see this command. Go ahead and run that cell now. Click on it or press Shift-Enter, or click the play button. While that's installing, you should see some output showing the packages being downloaded. This installs Cerebrus and LangGraph. First, let's talk about the brain of our operation, the LLM. For today's workshop, we're using Llama 3.370B, which is from Meta's latest family of open source AI models running on Cerebrus for lightning fast inference. Speed is always critical here, especially when we're conducting hundreds of AI interviews with multiple AI users and questions. Every millisecond counts. With Cerebrus delivering over 2,500 tokens per second,
Wow.
We can simulate an entire research study, 10 personas, 5 questions each, plus analysis in under 60 seconds. With traditional inference, this could take upwards of 20 minutes. So with Cerebrus, you could run 20 user simulations in the same time it would take you to run one with other platforms. And as a final note on Cerebrus, this is the AI processor running these models, the Cerebrus Wafer Scale Engine WSE3. It's a massive AI chip that delivers the fastest inference in the world. As you can see in the benchmark, we're delivering over 2,500 tokens per second with Llama 3.3, 5 times faster than the next best provider.
And the second platform we're going to be using here is LangChain and LangGraph. Today we're focused on LangGraph for workflow orchestration and LangChain for integrations, as well as structured output. We'll use LangSmith for tracing and observability. This gives us the building blocks to create complex, stateful AI systems that can handle multi-step research processes. We're going to be using 3 key LangChain features today: model abstraction, so we can easily swap different providers; standard interfaces that make our code clean and maintainable; and structured outputs to ensure that AI responses are properly formatted. These features let us focus on the research logic instead of wrestling with AI SDKs. Now, LangGraph gives you low-level components for building many types of AI applications, including agents or workflows. And we can lay out these applications in any way we want, as a series of steps or nodes. Each node is just a Python function, giving you full control over the logic within each step.
Think of it like having a team of AI researchers, each with their own expertise, working together seamlessly.
We connect those nodes or steps into a workflow. We start with configuration. This just generates the personas, runs interviews in a loop, and then synthesizes results. LangGraph handles all that orchestration and state management for us.
The beauty is that each node can focus on one job really well, and LangGraph connects them intelligently. For our second step now, let's set up our LLM running on Cerebrus. Our LLM is the brain of the operation and handles question generation, persona creation, simulated responses, and analysis. This function is our interface to Cerebrus, and we'll be calling this function multiple times throughout our code.
For step 3, let's talk about state. As we conduct all of these simulated interviews, we want some way to track the shared information across each of these steps and nodes. LangGraph has a state object, which we can access within each node, and update once we finish running the node. So because every node can read from and update this state object, it can track our questions, personas, or anything else we want over the course of this research process. Now, without proper state management, AI systems can't always maintain context across time.
Look at how the state flows through our system. Each node reads what it needs and updates what others will use. This shared state is what makes our multi-agent system coherent instead of just a bunch of disconnected AI calls. Now, look at the interview state type dict. It defines exactly what information flows through our system: research questions, personas, interview tracking, and final results. This structure keeps everything organized.
Now for our next step, we need to build our specialized agents. So each node is a specialist that performs one specific task and updates the shared state, which other nodes can then use.
This is where the magic happens. Each AI agent has a clear job and does it really well. The key insight is that nodes don't just process data, they update a shared state. This lets subsequent nodes build on the previous work. It's like a relay race where each runner hands off exactly what the next runner needs. For our workshop today, there are 4 main nodes. Each has a specific role in the research pipeline. The configuration node is our first node and is our entry point. It gets the research question from the user and generates interview questions automatically. This node will initialize our research process. It prompts the user the research topic and types of users we want to interview. It then generates a configurable number of questions about the research topic to seed our interviews. The second node is the personas node, which creates diverse user profiles with rich characteristics, different ages, backgrounds, communication styles, everything that makes interviews realistic. This is where we get the diversity that makes our research valuable. Each persona brings a different perspective.
So once we have our personas in the third node, which is our interview node, we can just conduct interviews, which is actual QA simulation. Each persona responds in character, maintaining their personality throughout. And this is really the most complex node because it's where it has to manage the conversation and flow between personas and keep them consistent. The last node is our synthesis node. It analyzes all the completed interviews and generates actionable insights. It looks for patterns, themes, and practical recommendations. This is where raw interview data becomes business intelligence.
For the next step, we need to set up our router. In our flow, 2 things can happen after an interview is completed. Our program can move on to the next persona, or if we've gone through every single interview, we can end the program. The interview router decides what happens next. Continue interviewing the next persona or move to synthesis. This is what makes the workflow intelligent and adaptive. It's simple logic, but it's what makes our system autonomous. No human intervention needed once it starts.
And now we just connect everything together, add the nodes, define the connections, set up conditional routing, look at the build interview workflow. It's surprisingly clean for such a powerful system. So LangGraph handles all the complexity for us. We just define the structure and it manages the execution.
Finally, the moment of truth, let's see it in action. We can input a question and our target persona. Watch how it generates personas with distinct personalities, conducts interviews where each persona responds differently, and synthesizes insights.
So from research question to actual insights in under a minute, that's really the power of AI automated research.
Great. Now we have a fully working AI-powered user research system, but let's keep going and make it even more robust. This part is completely optional, but here are a few ways that you can expand your code. A worthwhile expansion is to implement multi-question interviews. Instead of getting asked a series of individual questions, the agent is able to follow up and dig deeper into an interviewee's response, creating more natural conversations and uncovering deeper insights. Some of our key changes is that we've implemented enhanced state. So we've added follow-up tracking and conversation context. We've added a follow-up generator. So the AI creates contextual follow-up questions based on the responses. We've added a smart interview flow. So it decides when to follow up or move to the next question. Conversation memory, so personas remember and build on previous answers. And finally, enhanced synthesis. So analyzing the conversation patterns for deeper insights.
Another thing you can do here is use LangSmith to understand what's happening under the hood. You can look in detail at the interviews between your personas and the responses. And this is really essential for auditing quality, finding bugs, or tracking costs. Building effective AI applications often requires 2 central things. Look at your data, set up evaluations to test performance as you update, for example, models over time. And LangSmith is a great way to do both of these.
You can see exactly how each node performed and optimize your prompts and logic. And that's it. In less than an hour, you've built a sophisticated user research system that can generate personas, conduct hundreds of user interviews, and to synthesize actionable insights in seconds.
Remember, you've all the starter codes. Keep experimenting. Try adding your own research questions, customizing persona generation for your target demographics, or expand the interview flow with follow-up questions. You can also think about using new models as they come out and are available on Cerebras.
If your research system isn't working perfectly right now, don't worry. Sometimes it takes a few tries to get the API connection set up correctly, or you might need to refresh and run the cells again.
The most important thing is that you now understand the LangGraph architecture and have complete working code to take with you. You can adapt this for any type of user research, like product validation or market research. So happy researching.